In this video, I'm going to show you how to compare the steepness of lines given in different formats to each other. The three formats we're going to be looking at are fractions, percent grade, and angle of elevation. So the idea is going to be that we're going to need to convert these three into the same format so we can compare them. So let's read the question and see how we can handle this. Carter is building an accessibility ramp and has found three different plans for ramps. Ramp X has a slope as a fraction of 5/30 seconds. Ramp Y has a grade of 15%, and ramp Z has an angle of elevation of 9.4 degrees. So the idea is going to be that we need to compare these three things in the same format. So, theoretically, we could try to get a fraction, but to compare fractions, you need the same denominator. That's just a whole mess. That's a really inefficient approach. We could turn everything into a grade, and that would be fine. It's going to turn out that it's one extra step that we don't have to do for these two questions. The worst choice would probably be, well, aside from fractions, but turning them all to an angle of elevation wouldn't be terrible, but it's more work than we have to do. The easiest way to compare these three is going to be slope as a decimal. Now, the slope as a decimal is going to be really simple for these two. We aren't even going to need a formula, and it's going to turn out to be just one step here. And as soon as we've got all three of these slopes as decimals, then we can just compare them from least to greatest. So let's start with the fraction. So ramp x is a fraction. It is 5/32. And to turn that into a decimal, all you need to do is just 5 divided by 32 in your calculator. So I plug that into my calculator. I get 0.15625. I'll just keep 3 decimal places. That should be enough to compare. So rounded correctly at 0.156. Ramp y is a percent grade, and there are a couple ways that we can turn a percent grade into a decimal. One way, if you know the conversion, percents you can turn into decimals. You can memorize this by dividing by 100%. Or the way this works, 100% is 1, literally. So all that we're doing is converting our percents into decimals by converting by our scale factor that 100% is 1. So you take your 15%, you divide by 100, you get 0.15. Since I did 3 decimal places here, I guess I'll add a 0 at the end as well. So it's also 3 decimal places. The other way is percent. Percent literally means per 100. So we could take this 15% and make it 15. Per means divided by, so we could do 15 per 100. And 15 divided by 100 is 0.15, 0 to make it 3 decimal places. Now this next one here, this angle of elevation, there are two formulas for working between slopes and angles of elevation. First of all, for our formulas, for slope, we're going to be using the letter M. M is usually the typical letter used for slope. And angle of elevation, we're going to use theta. That's the typical variable used for angles. So the two formulas are these. Your slope is the tangent of your angle of elevation. Tangent is it's a trigonometric function. For this video, you just need to know that tangent is a button on your calculator. And if you do tangent of an angle, it gives you your slope. And above tangent on your calculator, you'll see it says tan minus 1. The way we read this is tan inverse or tangent inverse. And that tan inverse of your slope gives you your angle of elevation. Now, in this case, we want our slope as a decimal. So we're going to want this formula that turns an angle of elevation into a slope. So for Z, we're going to use this formula here. M is tangent of our angle of elevation, which is 9.4 degrees. So plug this into the calculator, get 0.1655 and so on. So because it's 5, I'm going to round it up to 0.6, an extra 6, so 0.166. And there we go. So now we've got our three angles, or our three slopes, going from least middle, highest, comparing them. Now, just a word on why I did 3 decimal places. So I was pretty careful to make sure that it was 3 decimal places in all 3 of these things. And the reason is because a mistake I often see students make, this isn't this question, but often I'll see students say that 0.7 is less than 0.65 because they say, oh, 65 is more than 7. And this is incorrect. The mistake that students make here is that 0.7 is actually, you can sort of fill in a 0 here. It's actually 0.70, and 70, well, 70 is actually greater than 0.65. And so if you keep the same number of decimal places in all of your numbers, then you're going to avoid making that mistake. So in this case, here we go. Y, our grade is the least steep at 150. The next steepest is 156, which is ramp x, our fraction, and our steepest of all is the angle of elevation, 9.4 degrees.